Good afternoon, sir. Myself, Anwesha Ghosh, and today I have come with the topic Amplitude Modulation as the topic for CA1. So, as we know, according to the information, as we know, amplitude modulation is something like it's a process in which the carrier amplitude is varied in accordance with the instantaneous value of modulating signal, and this whole thing is known as amplitude modulation. So this is a presentation, PowerPoint presentation I have made, which defines amplitude modulation principles and its applications. The contents which I have covered here are basics of amplitude modulation, types of amplitude modulation, technical aspects of amplitude modulation, advantages and disadvantages, and its applications. So, basics of amplitude modulation. As we know, amplitude modulation or AM, it's a technology where it consists of low band, upper band, carriers. Also, we will come across a term known as frequency. As we know, it's like there are two types of modulation: amplitude and frequency. But today, my topic is on amplitude. So amplitude modulation modifies the carrier wave's amplitude, that is the signal intensity, in accordance with the message signal, such as audio signal, that is a modulating signal. So definition and principles. As we have came across what is amplitude modulation, their amplitude modulation consists of many subcomponents such as carrier signal oscillator, low power amplifier, an antenna, final amplifier, modulation device, and etc. Also it contains informations which is like transmit not transmitted, like the information is carried. So we will also come across a term known as modulation index, which indicates how much modulated variable of the carrier signal varies around its unmodulated level. So, key components of AM, that is amplitude modulation. The key components of amplitude modulation includes the carrier wave, modulating signal, and the resultant amplitude modulation wave, which combine to form the complete transmission signal. Now, as we have came across the short abbreviation, that is the mu. We know mu when it becomes lesser than 1, it's under modulation. When it's greater than 1, it's over modulation. And when it's equal to 1, it's critical modulation. These are the various. Now, mu, what is mu? Mu is am, that is am by al, which we will come across in the further slides. So modulation process that is explained over here. The modulation process involves varying the amplitude of the carrier wave in proportion to the instantaneous amplitude of the modulating signal, creating fluctuations that carry the information. Now, spectrum and bandwidth. What is spectrum? What is bandwidth? So, bandwidth, as we know, bandwidth is the difference between the upper frequency and the lower frequency. That is, upper frequency minus the lower frequency. So frequency spectrum of amplitude modulation is described over here. That is, the frequency spectrum of this signals consists of the carrier frequency and two sidebands representing the upper and lower frequencies that contain the audio or video information. Now, what kind of information do we send? Like, not we, but what kind of information is sent? That is audio, video, kind of um, when we open a radio signal, we will come across it for in the further slides. Now, what is bandwidth? as I have said, bandwidth is the upper frequency minus the lower frequency, and after solving, we get BW equals to 2 FM. The bandwidth required for AM transmission is typically twice the highest frequency of the modulating signal, ensuring that all the information is transmitted without loss. Now, sidebands in AM signal. Now, we will come across how many types of AM signals are there, like USB, SSB. We will come across that. Types of amplitude modulation. So, if we say how many kinds of modulations are there, we can say there are three types or two types, mainly SSB and VSB, that is the single sideband or the vestigial sideband. Um, Standard amplitude modulation. Characteristics of standard amplitude modulation is characterized like by the ability to vary the amplitude of the carrier wave in accordance with the message signal. It typically has a bandwidth that is double the frequency of the modulating signal. And what are the applications of standard amplitude modulation? The like radio broadcasting, allowing for the transmission of audio signals over long distances, making it a popular choice for news and talk radio stations. Coming on to the next slide, we have SSB. Now, what is SSB? It's a kind of scheme in which only one sideband, LSB or USB, is transmitted, is known as SSB transmission, like which requires only one way of the bandwidth of the DSB signal. Like these have other two parts like phase shift method, vestigial sideband system. We will come across that. Now there are advantages of this SSB. SSB is more efficient than standard AIM as it uses less bandwidth and power while reducing noise and interference. This allows for clearer communication over long distances. Now, what is SSB generation techniques? How, like, how many techniques are there and what are the techniques? SSB can be generated using various techniques, including filter methods, phase shift methods, and product detection methods, each offering unique benefits in terms of performance and implementation. So now we can come across a question like what is the difference between DSBSC and SSB, like DSB and SSB. The slide like this. What is the difference between DSB and SSB? So the difference we can say now, like the bandwidth which we have came across, the bandwidth required in DSB is required lesser, and in SSB it was required is the bandwidth required is least. And in DSB, only two sideband with suppressed carrier is transmitted, and in SSB, only one sideband is transmitted. And these two types have two types of waveforms. Now coming on to VSB. What does VSB stands for? VSB stands for vestigial sideband modulation. Now, like if more information is to be broadcasted in a given time, then corresponding larger bandwidth is required. For example, we can take television. So here is the application in television. VSB is primarily used in television transmission, which is efficiently which where it efficiently carries audio and video signals. Then we come across VSB characteristics. VSB modulation retains a portion of one sideband and a vestige of the other, allowing for improved transmission properties, reduced interference, and enhanced signal quality in both analog and digital broadcasts. So, this is the diagram. I'm sorry. This is the diagram how VSB signal is generated and transmitted. Now, coming on to the next slides. What are the advantages and disadvantages of AM? So here is a diagram where it's described what is how a waveform of modulating signal is shown, a carrier wave is shown, and an amplitude modulated wave is shown. Now benefits. There are many benefits of amplitude modulation like simplicity of implementation. Amplitude modulation is straightforward to implement, requiring basic circuitry and limited components, making it accessible for both amateur and professional engineers. Then, sorry, I'm sorry. Hmm. So compatibility with existing equipment. AM signals can be easily used with existing radio infrastructure, including most radios and transmitting stations, allowing interoperability, and reducing the need for new equipment. Next slide, we have drawbacks. So, drawbacks of amplitude modulation is that noise accessibility and inefficient bandwidth usage. Um, Next slide, we have application. As we have came across, it's mainly used in radio broadcasting, then talk where news in news channels and all, for news recording. This type of things are required. This thing is required. So in radio broadcasting, AM radio transmission allows for broadcasting audio signals over long distances, providing reliable medium for news, music, and talk shows, especially in remote areas. And global AM broadcasts utilize high power transmitters to reach um, audiences across vast geographic regions, enabling international radio services and cultural exchange. Now, other applications we have two-way radio communications and television signals. Like in two-way radio communications, they rely on amplitude modulation for the voice they need, the voice that is transmitted, and they are commonly used as like emergency communications. It is used for emergency communications, police, and aviation. And for television signals, we have it is used to transmit audio components, helping to synchronize sound with video, particularly in older analog TV systems. So these were the applications of AM, that is amplitude modulation. Thank you.